Okay. So, first part of the session, I will discuss the doubts related to paper 2, and then we'll start the discussion of a mock paper 4 set 1. The diagram shows a structure of a polymer, which structure represent the monomer. How you can identify the structure of a monomer from the polymer? First thing, you identify what kind of polymer is this. When you see a carbon-carbon link is there, like carbon atoms are linked with each other, so it means this is addition polymer. So in addition polymer, how to work out the monomer? You just take the first two carbon, and what is attached to the first two carbon, you take it out. So these are the two carbon. This is CH3. This is H. This is C, double bonded with O, and H is there. And this is H. And if I need a monomer, what I have to do to form a monomer? I just have to convert this a single bond into a double bond. Then it has turned into a monomer. For those who just joined now, these are some questions related to paper 2, as some students have mock tomorrow. So I'll first answer these doubts, and then inshallah we'll do uh, paper 4, mock paper 4 set 1 discussion. So if you want to work out the monomer from the structure, what you will do, you will take the first two carbon atoms and draw the same structure, but with a double bond. Now we'll check which one it match with. Like if I rearrange this structure, so it means like if I draw in a straight line, this is C double bonded with C. Next to that is a carbon, C double bonded with O, and H is there. There's a hydrogen attached. With this carbon, there's a CH3 attached. And the carbon hydrogen is attached. So does it match with option A? So it does not match with option A. As you can see, the carbon-carbon double bond is there. It has two hydrogen. But for us, the carbon-carbon double bond, one side is a hydrogen, another one is a CH3. This one is also wrong. Carbon-carbon double bond, CH3 is there, but there is no H. For this one, carbon-carbon double bond, H is there and CH3 is attached. And next to that is H is there and C double bonded with OH, C double bonded with O, and H is attached. So it means it matches with option C. Is it clear?
Yes, sir.
The next is the information about four substances W, X, Y, and Z is shown. As you can see, their melting point and their conductivity, conduction of. Yes, I will repeat. Look, the previous question, the question was which structure represent the monomer? First thing, it's an addition polymer because it is linked with a carbon-carbon. Like all carbon are linked with each other. Whenever you want a monomer from the addition polymer, what you do, you take the first two carbon atoms and take out what is attached with the first two carbon atom. So we'll have the two carbon atoms. Next to that is CH3 is attached. H is attached here. And with this carbon, H is attached. And then C double bonded with O and H is attached. And because it's a monomer, we want to form a monomer. So if it's a monomer, there should be a carbon-carbon double bond. So there's a carbon-carbon double bond here. Now we want to check which one matches with the structure of the monomer. Which one matches with the structure of a monomer? Like carbon-carbon double bond. These are the two carbon atoms which are having a double bond. With one of the carbon, there is hydrogen. So there is a hydrogen. And next to that is CH3 attached. So next to that is CH3 attached. With the second carbon on the right hand side, there's a hydrogen attached, and next to that is C double bonded with O and H is attached. So means option C is the right answer for this. So we simply have to identify the structure of the monomer by taking the part of the polymer. The next question is, we have substances W, X, Y, and Z. we have graphite, polyethylene is there, sodium chloride is there, and silicon dioxide, but not in order. The first one, it is having a high melting point. So it can be graphite because it's having a high melting point is there. It can be sodium chloride because of a high melting point is there. It can be silicon dioxide because of the high melting point, because 1700 is high. Then does not conduct electricity when solid. So in a solid state, it is not conducting electricity. That one information is given. About X, it conduct electricity when solid. It has a high melting point and conduct electricity in solid. So what this give an indication, because high melting point are there, W and X both have high melting point, but the conduct electricity in solid, the graphite, which is having a delocalized electron, the free electrons are there. So graphite can conduct electricity. So means X should, we identify according to the property, we identify X should be graphite. So either we can have D as an answer, or we can also have B as an answer, because it is conducting electricity when it is solid. Then 120 low melting point and does not conduct electricity. So what this give an indication? This give an indication that it is polyethylene. Polymer is there because polymers does not have free electron and they have usually like low melting point. So this give an indication that the Y should be polyethylene. So it can be B or D again. But 801 and conduct when molten. So it is conducting electricity when it is molten state. So we know ionic compounds does not conduct electricity in solid, but ionic compound can conduct electricity in molten and aqueous. So this give an idea that this is a sodium chloride, NaCl. So Z should be a sodium chloride. And what about W? So W is because it is having a high melting point and not conducting electricity in a solid state. This give an indication that this is a silicon dioxide, because silicon dioxide it has a similar properties as diamond, high melting point, and does not conduct electricity in a solid state. So Z, how we identify it's a sodium chloride? So how we identify Z is a sodium chloride? Because it is conducting electricity in a molten, and this is a characteristic of the ionic compound. And which is an ionic compound? Sodium chloride is an ionic compound. Is it clear? This one?
Yes, sir.
Look, when we identify the substances, we have to check which property. Silicon oxide does not conduct electricity because silicon dioxide, it has a giant molecular structure and there is no free delocalized electron or no free ions to allow the electricity to pass through. That's why the silicon, this high melting point, it does not conduct electricity. Give an idea, it's a silicon dioxide. High melting point and conduct when solid. So this give an idea, it's a graphite because we have option in a graphite. Low melting point, it does not conduct electricity. So this give an idea, it is a polymer, polyethylene. And high melting point and conduct on when it is molten. So this give an idea, it's an ionic compound, and ionic compound here is a sodium chloride. So silicon dioxide does not conduct electricity because it is not having free electrons or ions. The structure of a glycine is shown. Which row is correct? Formula. What is the formula? You count the number of the carbon, hydrogen. So how many carbon atoms are there? 1 and 2 carbon atoms are there. So we write C2. How many hydrogen atoms are there? How many hydrogens are there? 1, 2, 3, 4, 5. So C2H5. How many oxygen atoms are there? There are two oxygen atoms, 1 and 2. And how many nitrogen atoms are there? So number of the nitrogen, it is 1. So C2H5O2N. Like which one it match with? This contain one nitrogen, okay. This contain two oxygen. It contain five carbon, but sorry, five hydrogen, but one carbon. This contain one nitrogen, two oxygen, five. So C2H5O2N. So either B can be an answer, C can be an answer. What about D? When we check D, it has 1, 2, 3, 4 hydrogen, but we need 5 hydrogen. So it cannot be D. So either B can be an answer or C can be an answer. How many number of different elements are present? How many number of different elements are present? So it contains carbon. This is one, hydrogen, oxygen, and nitrogen. So B should be the right answer for this, not C. Because they did not ask the number of the atoms. They asked number of different elements in how many number of different elements. If the question was how many different atoms are there? 5, 6, 7, 8, 9, 10. If this was the same question and number of not different atoms, if the question was number of atoms, then we'll write 10. But they ask for element. Even I have like example 2 nitrogen, I have 3 nitrogen, I will have 5 nitrogen in a molecule, but I will count that as 1. Like I will count that nitrogen is one element. So in a different number of elements, 4 different elements are present. So not B, it should not C, it should be B. Which piece of apparatus is used to measure 24.5 cm cube of a gas produced during the reaction? We want to measure a gas specifically. So conical flask, we take a solution normally to swell the mixture. We use a conical flask. A beaker is there. We can use a gas syringe or inverted measuring cylinder or measuring cylinder to measure the volume. Volumetric pipette is for liquid. Conical flask for the liquid. Beaker is for liquid. Measuring cylinder can be used to measure the liquid or a gas. So if you remember like some experiments, when a gas is given off during a reaction, so we can collect this gas over the surface of a water by using the inverted measuring cylinder. So inverted measuring cylinder, like measuring cylinder first filled with the liquid. When a gas is given off, the gas will take the place of the liquid. The liquid will move out and we can measure how much volume of a gas is there. So a measuring cylinder can also be used to measure the volume of a gas. But rest all of them can only be used for the liquids only. Because the question was specifically about the gas. Is it clear?
Yes, sir.
So the color of thymol pethylene, this is a repeated question. Even in the paper 4 also I give the color of a thymol pethylene. So what is the color of the thymol pethylene in alkaline medium? In the question, yeah, in alkaline medium, thymol pethylene is blue. If you have an alkali. What is the color in acidic solution? Hydrochloric acid.
Colorless.
Colorless. So it's related to memorizing the color of the indicator. Same thing, learned the methyl orange as well. Learned for methyl orange, phenolphthalein. Color in alkaline medium for thiamolpethylene is blue. In acidic medium, it is colorless. Indicators are usually weak acid. Universal indicator. Universal indicator color depends on the pH. Usually hydrochloric acid, which is a strong acid, so it is red in color, the universal indicator. But universal indicator changes its color at different pH. Like example, pH 1, 2, 3, 4, 5, 6, 7, and so on. So it is red in this range, then it is orange, yellow, green is there in 6 and 7, then it is blue, violet, and dark in purple in color at the last. But the universal indicator shows a different color and different at different pH. What about the universal indicator in alkaline medium? Same thing. You have to learn the color, like it can be blue when the pH is from 8 to 11. Then it is purple when the pH is above 12 or above. Yes, you have to memorize those colors. And why we cannot use universal indicator? Because the universal indicators show a transition of the color. So it is hard to recognize the color change, continuous color change. That's why we don't prefer universal indicator. In the question, the graph shows the yield, how the yield or the product of a reversible reaction changes as the temperature and the pressure change. And all reactant and product are gaseous. Which row is correct? For first thing, when we talk about the pressure, on x-axis we have a pressure, and on y-axis we have the amount of a product, the yield. At high temperature, you can see this high temperature, we have a greater product as compared to low temperature. So what kind of reaction is this? Endothermic or exothermic? First, at high temperature, we have more product, and at low temperature, we have less product. So what is a forward reaction? Is it endo or exo? The forward
Endo.
reaction is endo. Because when we increase the temperature, how we say it is more, you can compare the graphs, starting point of the graph. Like this is a graph which is done at 300 degrees centigrade, and this is a graph which is done at 100 degrees centigrade. So higher yield means like more product. At 300, there is more product as compared to starting of 100. So this give an indication that at higher temperature, you have more product. If higher temperature, you have more product, means the equilibrium has shifted towards the right-hand side. So forward reaction is endothermic. So either B can be an answer or C can be an answer. Then, when you check the pressure, on x-axis, you have a pressure. If you compare at high pressure, like what happened to the yield? Yield is decreasing, because if you see the graph, when the pressure is increasing on x-axis, what happened to the amount of a product for both reactions? The amount of, or for the same reaction, the amount of a product is decreasing. If the amount of product is decreasing, and what is the rule? Whenever for a reversible reaction, when we increase the pressure, equilibrium will shift towards side of a less moles. So as you can see, when we are increasing a pressure, the amount of a product is decreasing. So if amount of a product is decreasing, it means where the equilibrium has shifted towards the left-hand side. And whenever we increase the pressure, equilibrium will always shift towards side of a less moles. So it means we will have less moles of the reactant and we'll have more moles of a product. So whenever we increase the pressure, the balance always shifted towards side of less moles. And how we identify it is shifted backward, because the amount of a product is decreasing, or the amount of a reactant is increasing. So which side will have the few moles? So in the reactant side, we will have the few moles. Is it clear? So for a reversible reaction, okay, I'll repeat. Look, if you have a graph. Let's say this was a question. I have A and reacting with B and forming a product C, and all of them are a gas. If I increase the pressure, where the balance will shift? Right or left? If I increase the pressure, where the balance will shift?
Right.
Right or left?
Right.
Right.
So here we have 2 moles and here we have 1 mole. So if I increase the pressure, increasing a pressure shift the equilibrium towards side of less moles. So in this case, when I increase the pressure, it will shift toward the right hand side. So if I sketch a graph for this result, if I sketch a graph for a pressure and the yield means like the percentage of amount of a product. So what should be the shape of the graph? That as I'm increasing a pressure, the yield is increasing. So the graph should be like this. If I have another equation in which we have A plus B and giving 3C. So gas, gas and gas. And I'm increasing a pressure. Increasing a pressure always shift the equilibrium towards side of less moles. Where the balance will shift now?
Left side.
So it will shift toward the left hand side. If the balance will shift towards the left hand side, what will happen to the yield or amount of a product? If the balance shifted toward the left hand side, yield or amount of product will decrease. So what will the shape of the graph? In that case, what is the shape of the graph? So this will be the shape of the graph. So if we have this is always the same. This is always the same. So whenever you have a reversible reaction, and you increase the pressure and the yield is decreasing, it means the reactant have less moles and the product is having more moles. If this was a graph like this, then the pressure and the yield, then what will be the case? In that case, the product will have less moles and the reactant will have more moles. Is it clear?
Yes, sir.
Why it is endothermic? Because in the question, you can see when the temperature is high, you have more product. When a temperature is low, you have less product. So for endothermic reaction, increase in temperature gives us more product. That's how we identify. If this was a graph like this, if I change the order, like example, 300 is below, at 300, this is 300 and this is 100. Now, at low temperature, you have more product and at high temperature, you have less product. At low temperature, you have more product and at high temperature, you have less product. So what this give an indication? This give an indication that this is an exothermic reaction. Because exothermic reaction, we get less product at high temperature. In this question, the property of elements are shown. It has a good electrical conductivity. It has a low density. It can react with water, react violently with the cold water. Which element will have these properties? So first, electrical conductivity is good, so it must be a metal, should be there. So either C can be there, A can be there, B. Density is low. Which elements have a low density? If you learn the characteristic of alkali metals, what are the characteristic of the alkali metal? They have low density. Like C cannot be because C is a transition element. Same thing for alkaline earth metals. They also have a high density. So reaction with water, it's a violent reaction with the cold water, react very fast. So this matches with the description of the alkali metals. Why not A? Because group 2 elements are not having low density. They have high densities. like calcium, magnesium, strontium, barium, they all have high density. The characteristic that the group 1 specifically is having, they have low density compared to any other metals in the periodic table. So this characteristic indicate that this should be an alkali metal. And a violent reaction is there with the cold water. When we check, they usually for group 2 metals, they do react, but their reactions are not violent with the cold water. They can react with steam easily, but with the cold water, very slow reactions are there. And it is reacting violent means it is more reactive. So as we go down the group, the reactivity also increases for the metals. The periodic trend for, you have to learn a periodic trend for group 1, group 7. Group 1, as we go down the group, what we'll observe, the reactivity increases. But for group 7, the halogens, what we'll observe, the reactivity decreases. When we talk about the melting point, as we go down the group, the melting point decreases for group 1. But as we go down the group, the melting point for group 7 increases as we go down the group. Like fluorine and chlorine are gas, bromine is liquid, and iodine is solid. Then when we talk about density for all the elements in the periodic table, the group, it always increases. So even for group 7 or group 1, the density will increase. And the tendency, the group 1 have a tendency to lose electron, form a positive ion, where group 7 have a tendency to gain electron and form a negative ion. And group 7 elements exist as a diatomic molecule like fluorine F2, chlorine Cl2, bromine Br2, iodine I2. Which row describe the formation of a single covalent bond in methane? What happened in a methane? A carbon forming a bond. How does D is having a low density? Who said D is having a low density? This is a group 1 element. Group 1 element, they all have low density compared to others. That is a general characteristic of a group 1 alkali metals. When we compare them in their groups, like example, down the group density increases. That is a comparative property. But general property with other metals, the group alkali metals, they have low density. Which row describe the formation of a single covalent bond in a methane? How a covalent bond is formed in a methane? Carbon belongs to group 4, share 4 electron, one with each hydrogen. And hydrogen also reaches a noble gas configuration. How it reaches a noble gas configuration? Because hydrogen was having 1 electron in the first shell. When it shared, there's another electron, so it completed the shell because the first shell can have 2 electrons. And carbon also completed the noble gas configuration. How? It has 8 electrons now in the outermost shell after sharing. So whenever atoms are sharing electrons, they always try to complete a noble gas configuration. Like if it was a case of a ammonia, nitrogen bonded with a hydrogen. So hydrogen also have noble gas configuration because 2 electrons, and nitrogen also reach a noble gas configuration having 8 electrons. According to the, so whenever there is a sharing of electron between the atoms, they always reach the noble gas structure. Why it cannot be B? Because both atoms have the same number of electron in the outer shell? No. Hydrogen is having 2 electron in the outer shell after forming a bond, where carbon is having 8 electrons in the outer shell after forming a bond. Like this is a carbon, and here it share 4, one with each hydrogen. So when I draw the circle of the last shell of a carbon, 1, 2, 3, 4, 5, 6, 7, 8. And a hydrogen is having only 2 electron in the outer shell. The next is propanoic acid is a carboxylic acid. It has a similar chemical properties of ethanoic acid. Which statements are correct? Aqueous propanoic acid is weaker than dilute hydrochloric acid. When we check all these carboxylic acid, like if I have a methanoic acid, if I have ethanoic acid, if I have propanoic acid, they all have a tendency to lose proton. When they lose proton means like the hydrogen will be lost, but it will ionize, weak ionization is there. They all are weak acids, the carboxylic acid. So aqueous propanoic acid is weaker acid than hydrochloric acid. Yes, this statement is true. No, whenever they lose the electron, whenever they lose, they all of them, irrespective of how many hydrogens are there, they all are losing the last hydrogen which is attached with oxygen. Like if I have ethanoic acid also lose this hydrogen. If I have a propanoic acid also loses this hydrogen. If I have a butanoic acid, so all of them are losing one proton, one hydrogen, and they are ionizing partially. That's why they all are weak acids. So it's not about how many hydrogens are there, it's about how many hydrogen loss. All of them loses one hydrogen when they mix, and it's a weak ionization, like weak ability to lose electron or turn into an ion. So statement 1 is correct. So any option with 1 is the right. Propanoic acid partially ionized in aqueous solution. Yes, that is a characteristic of the weak acid. So any statement with 2 is also correct. But this does not have 1, so it's wrong. Like 2 is correct, but there's no option of 1. Propanoic acid react with ethanol to form propyl ethanoate. So when alcohol react with a carboxylic acid, it will form an ester. The first name of ester is from alcohol and the second name is from the acid. So if ethanol react with propanoic acid, what is an ester it will form? It will form ethyl propanoate. But it is written propyl ethanoate, so this ester cannot be formed. So statement 1 and 2 are correct, where statement 3 is incorrect because the ester which is formed is a ethyl propanoate, but in this example, the option they give, it is forming propyl ethanoate. Petroleum is important fossil fuel. Which row correctly describe petroleum? Petroleum is what? It's a mixture of the hydrocarbon contain carbon and hydrogen. Why it's written mainly? Because there are other elements are also there, like fossil fuel also contain a trace of sulfur. So mainly hydrocarbons are there, and it is not a compound, it's a mixture. That's why C is the right answer. Like it contain, it give octane, paraffin, naphtha, different fractions are given off, but this is not a compound, it's a mixture of the different compounds. And it mainly hydrocarbons means most of them are. Now, if you say only hydrogen and carbon, why it is wrong? Because there are trace of other elements as well. If we write the source of a sulfur dioxide, we write source of a sulfur dioxide, burning of a fossil fuel as well. So why we say a burning of a fossil fuel give a sulfur? Because this fractions of the petroleum do contain trace of a sulfur. A metal object is electroplated using a copper. One electrode of a metal object and other electrode is copper. The electrolyte is aqueous copper sulfate. Which row shows the ionic equation for the reaction at anode and observation of the electrolyte? One of the electrode is a metal object and the other electrode, this is called active electrodes electrolysis. Like we have one is made up of a copper, another one is made up of any metal, they did not specify. And the electrolyte, the solution is aqueous copper sulfate. So it means it contains copper ion, it contains sulfate ion, it contains hydrogen ion and the hydroxide ion. First, the less reactive will move, so the copper will move. Copper ion will move there towards the cathode, the negative terminal. When copper ion will move there, it will take 2 electrons from copper atom. Then, because the anode is made up of a copper, so as the amount of a copper changes, the copper atom go inside the solution as a copper ion. So what will the change here? The copper atom will turn into a copper ion by loss of electron. So size of anode will start to decrease. And what happened to the solution color? It won't change, because when one copper is going out, another copper will enter the electrolyte. So there is no change in the color. Why the color does not change? When one enter, one goes out. So overall concentration of the copper does not change in the electrolyte. And what happened to the size of the anode? The size of the anode will start to decrease. The size of the mass of anode will decrease and the mass of a cathode will increase. And why the size of anode is decreasing? Because a copper atom turned into copper ion by loss of electrons. So the copper atom turned into copper ion, that is happening at anode. And why there is no change in the color of a solution?